We'll start today with higher order functions. So just recap, basic expression and conditional expression is done. If loop, if else, if ladder, for loop, while loop, break a statement. Then object, it's a singleton object or companion object. This both things we have seen, right? Starting with higher order functions today. It's very useful, higher order functions in many cases. So you're putting less effort to do the big job. That's what I can say. If you want to apply higher order function or generic function or lambda functions, we'll see core functions part today. We have seen how to create a function. Now there are function types. First one is higher order function. Now, what is higher order function? Using one function, I can call another function. From function itself, I can call function, right? Or I can pass one function as one variable value or argument. I can pass this function as a function argument also. So all that I can play with functions, and there's a higher order function concept which is giving you flexibility to perform all that operation, which where we are saying calling function from function or uh, passing one function as a function argument. So in English, if I write higher function, you create two function, and that you're passing that two function with another function. So let's go and see the practical rather than discussing the theory, how it does. I'll try to create one higher order function here. So Scala, up to you. You want to create a class or object, but yes, if my job can be done using object, then I will not create any class. I'll give this name as a HOF. And by the way, this name is defined by user, right? So we pass the name HOF, we say okay. Then I'll create a main method, which is diff main. Basic rule of singleton object or in a Scala, I cannot create another function inside the function. I'll have to create this function outside the function. And how I'm calling inside and outside based on this parenthesis. So once this parenthesis is closing, this is the total function body. So my function which I'm going to create should not be a part of this. Okay, here I'll say diff function name, which I'll call as function name is high function. Okay, function name can be defined by user again. Then, let me do this two basic thing first. I'll create one function as paid function, and then I will call create two argument x comma y. X is integer, y is also integer. First I'll create it, then I'll explain you. After 8, we will write the function body. So suppose I want to add two different values, right? I want to add x and y. Here I will write x plus y. This is a basic sum function created div, and I want to multiply again two arguments x and y. Their type of integer again, and in function body this will be x into y. Okay, you want to say this, and creating another function which is diff high So this two function we know, right? Because if I again write the function syntax, function syntax, we know what is the function syntax. We type def, then function name, whatever you want to give. Then we write arguments here, as many argument as we required. So suppose if I need one argument, I'll say argument 1 colon the data type, which is, let's say I'm taking float. So float, double, integer, big integer, long, all that you can take here. And that's why I'll write here data underscore type is equal to, here I will write my function body. This is the syntax and this is your function return type. So Scala takes by default if whatever is the data type here, and based on your function body, it will define the return type. So let me write here return type. If you see here integer and integer, I have not written. Scala has autocomplete option. So by default, Scala is giving me this two return type, which is integer and integer. Now I'm creating a function which can call these two function. I'm creating one function which can call these two function. Okay, that's what is a higher order. Now here I'll write f. So let me write first, then I'll explain you each terms. Integer, comma integer, transformation integer, comma op1 colon integer, comma op2 colon integer, and in the function body I'll say op1 comma op2. What I'm doing here, let's read from first f. This f is representing one function actually. This f is representing a signature of function. Instead of f, you can write anything from a to z. Okay, you can take any letter, not necessarily that f we are taking, but we're talking about the syntax. Now this f is representing the function which I have created above, which is add and multi. How many different variable we have? X, y, two variable is there, and both has a return type as integer and integer, right? So I'm writing this integer here and this integer here, integer, which means this function, this I'm trying to replace this function actually. I'm saying this function is add function. This f is representing add and this f is representing multi. If there are n number of function, this f will represent those function which are having two arguments. Integer comma integer is your two function return, two argument or argument return type, right? Then when you are creating this x and y, what is the function return type? This function return type is integer. That's why I'm writing here. This function transformation is giving me integer. So this we call the sign is representing you the transformation. Then op1, op2, these are two variables. This is transformation. op1, op2. So we know this part. The first part is nothing but replacing your function. Let me recreate. This first part is replacing your both the function add and multi, and you can match the signature. This f is representing this two value. This integer is for this integer. Suppose there are one more integer while creating the function, then you'll have to pass the integer here. So just mapping this. Then op1, what op1 is variable for x and op2 is a variable for y. So when I pass any value, how they will map with. OP1 and OP2 is type of integer. So I've given integer and integer for both. Then giving a function body. In this function body, this f is your function, which is this part, the complete part. OP1 and OP2 will be a runtime variable which will pass when you call this hi. It will be some value in integer. It will be some number when I pass it. Number 1 I can say, number 2 I can say. Okay. So this is a higher order function for this two function. If there are three integer, then you'll have to write like this. If there are suppose x, y, z, okay. So you'll say integer, comma, integer, comma, integer. So you just need to map this and check the number of arguments. How many arguments are there? Based on that, you create it, map with the function body. I'm going to call this function now. So calling cannot be done here. Calling can be done here. How can I call a function? I'll say hi, then hi, then I'll call this 8. So instead of this writing, I am writing the function name, which is 8. This is what you can call function calling function. Hi is a function, 8 is a function. And then you need to pass two value, 17, 8. I'm taking some random value. When I execute this, okay, when I execute this, it will give me answer as 17 plus 8, which is 325. So we'll get answer as 25. But if I do multi, sorry, HF multi, comma, I can pass any other value, 12, 3. This is high. So when I pass 12, 3, 12 into 3 will be multiplied because this value will map with your multifunction, which is multiplying two values. 8 is adding two values, right? But we have not written any print statement. So can I write this function to a variable? Can I assign one variable value is equal to this, right? Or let me say value result is equal to this. Print the result, addition of two binary value is res. And for this, I'll say another print statement before print assignment. Well, res1 is equal to print multiplication of two binary value. This is res1, right? Res and res1. You're just given that in the printed statement. Let's check this again from beginning. Since this is important in machine learning, in many places of Hadoop also, to avoid the situation of complexity, and we create a function which are calling a function. So first I have created one function which is adding two number. Then second I have created another function which is multiplying two number. Then I have created higher order function which is using the same signature as this. This is the same signature. Then OP1 and OP2 is X and Y. Then function body, how the function will be called. This is how I'm calling the function. This add is for F. This OP1, the 17 value is for OP1, and this 8 value is for OP2. Similarly for the multiplication also. After creating this three function, we have created one variable and assigned this function, because here your functions are first class citizens, right? Printing this statement, printing another statement. So output will come as 25 and 12 into 3 is 36. You'll see it here when I compile the code. So anytime when we are writing any functions or any classes, please write the same thing in your machine. You already have installed IntelliJ, create some project, start writing this. And don't try to redify, try to remember the flow, how your function flow is there. Because if Scala is not clear, then Spark will be difficult to understand. Spark is a programming model which runs on top of this Scala. Any programming language, by the way, Python, Scala, Java, logic is important. And this is the answer which I'm expecting, 25 and 36. But don't you think this looks more complex, right? Like creating two functions, then calling functions with another function, little complex. I will try to avoid those complexity again. And I will try to create a generic function. So higher order functions we have seen how to create, how to pass two functions. Second function we'll see is a generic function. Second function is a generic function. What this generic function will do, generic function will not ask you to create a function individually. You'll see it here. I'll say hash, oh sorry, double slash and double slash. We know double slash is a comment. Double slash is a comment. Then before going to generic, we'll see the third one. Generic we'll see at last. Lambda function. So there's three functions I wanted to discuss today. Higher order function, lambda function, and generic function. So how this lambda function will work? Lambda stands for anonymous. Lambda is a signature of anonymous. So if I don't want to create a function, I can call anonymous, right? Anonymous means you will have to write the logic only in place of function. So instead of creating this function, instead of creating this function and this function, can I write the logic directly in place of this? And what is the logic here for aid? Logic is this for aid, and multi logic is this, which is adding to number. Here for aid, I will write x comma y. And by the way, not necessarily x comma y, I can take any letter, a comma b, I comma j, k comma m. This can be anything. X comma y, which transform x plus y, right? This is what I'm writing. This xy is coming from here, x comma y. This x plus y is a function body. If I write instead of 8 this, then what is the benefit? Always we are focused on what programming benefit we are getting. Programming benefit is what? If you create this add and multifunction, they are taking some space in memory. This is taking some space in memory. And what is the space? X and Y. Both are integer and integer. So X 4 byte, Y 4 byte, integer and integer 4 and 4 8. So this 8 will take 8 byte, and this multi 4 and 4 will also take 8 byte, right? So 8 byte and 8 byte. Every time whenever I call this add and multiplication, then on CPU side they will occupy 8 byte of space, which is I think sometime unnecessary requirement. If I want to increase my performance or optimize my code, then I should not write this add and multiplication individually. I can use directly the lambda function or lambda expression. I can say function or lambda expression. That x comma y, x plus y, this is nothing but expression. And not just plus you can do any operation, right? You can subtract, you can multiply, you can divide, you can check modulus, you can use kind of all associative operation. In math, if I say, you can do all binary operation within two values. Can I do that? Can I create a lambda expression? I'll remove this 8, and instead of this I'll say x comma y, x plus y. That's it. So your function will automatically understand that you are trying to add to number because x plus y you have sent. And this is not taking any space. Whenever I call the res, whenever I print the res, they will check this high, take this two number and print it. They'll not occupy any space like add and multiplication because this is commented now. Similarly, here I will write x comma y, transformation x multiplication y. I'll keep this inside the body. I'll get the same answer, by the way. No changes. Check the output. It is coming as addition of two binary value is 25, and you can check any number here. You can pass 10 comma 10. It will do their job. So first answer should come as 20 and 36. But still I have some limitation in this, that I can only pass integer. Still one limitation is there, that I can only pass this integer value. So here I will apply the function to type, which is a generic function. Generic means it can take any data type, integer, double, float, based on the requirement. So let me go and give a function type, which is t. T stands for type is specific. And by the way, instead of t, I can write anything. T, f, x, y, any later. Scala in textbook, if you read, this is by default written as t, which is a type specific. Okay. Instead of this integer, I will say t, 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 t. Okay. So you're just replacing integer with a type specific, because currently while creating the function, you're not defining any function type or the return type. You're saying that when I'll call this function, that time I will tell you what is this type. In this way, you can use any data type. Let me use here a float. So when I'm calling the high function, I'll use that data type, which is float, and then I'll pass some value of float, 10.89f. Whenever you write any value with float, you'll have to use this f at last as a keyword. Then here I'll change this value as 13.45 f. Here I want to take value long. This is 120 comma 50 and print it. Can you see my function is one? I've created one function, but both the time my data type is different. One time it is float and second time it is long. So in both the cases, I am creating a different data types, float and long. Let's compile this. Right click and run. So you'll get the answer. Addition of this two value is giving me 24.34, and multiplication of this 120 into 15 is giving me 1800. This two is the answer. Now, after this function creations, we'll move to actual object-oriented programming side. So object-oriented programming, we have 6 pillar. Now we'll be discussing about that 6 pillar. And before that 6 pillar, there are few basic concept of constructor, right? How to create a constructor, how to access the constructor, how to do the constructor overloading, or what is the constructor. Now your function by default takes every time constructor. This println statement you're saying is nothing but a constructor, which construct an answer. That's what we call a constructor. Now why it is important, we'll see. Why constructor is important to optimize your code again. So the topic which we are starting now is a constructor. Constructor. First constructor is default constructor. So I'll tell you default constructor first. Any program cannot run without constructor. So that program is having one default constructor. Any program cannot run without constructor. So constructor is required by default. Second type is a primary constructor. Third constructor is a, I can call secondary constructor also. In Scala, this is known as a auxiliary constructor. Auxiliary constructor. Let's start with the type 1 default constructor. Okay. So first we'll see there are two parts to understand the constructor. First we'll understand what is constructor. What is constructor? Then second point we'll see difference between function and constructor. Difference between function and constructor. Let's start with the default constructor first. Creating one printf statement, a simple object, and give a name here, Scala call. This is the object. I'll create main method, and here I will write print hello Scala. This is what? This is a constructor only. Hello Scala, you are saying by default print is you are giving, print is working as a constructor. So it will construct one answer and display in your console. If I run if I run this line, right click and run. So whenever you write anything with print statement, that by default we call is a default constructor. Anywhere without print, we know that will not get any output. So print writes the output in our console and we see that output. So print is one default constructor, what you are writing inside the print statement. Second is a primary constructor. Second is a primary constructor. Now, where I apply this primary constructor? Suppose my requirement is this. I want to calculate. Question is calculate area of a flat. Calculate area of a flat. Okay, from one floor. So in one floor, let's say we have total 5 flat. In one floor, total we have 5 flats. Flat number is A901, then A902. A is a, let's say, building, and 901, ninth is the floor, and these are the flat. A903, A904, A905, and all has a different area. All this flats has a different area. Suppose the flat 1 is having length of 40 square feet, and width of or breadth of 26.00 square feet. So all this answer or number you're seeing this in square feet, a technical form of real estate. How do we check any area? And we know the formula of area. Area formula from math is length into width. Right? This is the formula for area. Second, length is equal to, I'll take another value 35.00, and width is 25.00. Here we have length is equal to 50.00 and width is 38.00. Length 45.00, width 20.00. The last is 1 BHK. So 1 BHK has a small area 25.00 and width is 16.00. This is the total 5 flat. Now, how to print or how to calculate this area? Are you creating 5 times area function? So here you will learn the use of function. Why you are creating function and calling this values? Because function will provide me reusability. Okay, what function will provide me? Function will provide me, it provides reusability. It provides reusability. Reusability means you're not creating 5-time function. You're creating one function and calling all these values to this function. That's what we're doing here using function. So let's use the simple function operation and try to build this. Then over this we'll see the constructor, why constructor is required. How can they increase the performance? I'll remove this. I'll remove this thing here, and I can do that job in directly here also. So let me create a. Let me try to prove this point using singleton object, and then I'll try to do that using class. I can write this operation by the way by both. Okay. So here is your function name, diff area. We are following the rule again. Function cannot be created inside the function. That's why I'm creating outside the function. So diff area, a length. So you can give length colon I'll give a float value because that is in decimal. Then width, this is also float. Then we want to multiply this value, length and width, length and width. Okay, function is created, and then I'm going to call this function. I will create one variable as well, A901. Then I'll call this function area. Let me try to create this A901 area. I'll pass two value and I'll take the same value, 40.0 and 26.00. So write those values, 40.00f, 26.00f. Similarly, I will write this 5 times, and at last I will change the value. So this is 902, this is 3, this is 4, this is 5. 35 5.0, 25.0, 50 and 38, then 45 20, last is 25 16, 25 and 16. After this, once you have created this, but where is the print statement? Print statement is not there. So I will create a print statement. Can I assign this len into width to a variable called, well, result? Can I store this to result length and width and print the statement with this? Because without print, it is not going to write any answer in the console. If I run this, I'll get the answer directly. Let me write print ln to get the answer in separate line. So this is your 5 answer of all 5 flats. But this is difficult to read, right? So can I say, well, print statement, I will write println statement, and here total area of flat A901 is whatever there. Then in that case, no need to write this print statement here. You can say length into width and start printing this. Take all this 5 times print statement, 902, 903, 904, 905. Right, this will give me some formatted answer, adding this string, and giving me the answer. Right click, run this. you get the same answer, but in some better form, which is talking about total area, flat 1, flat 2, flat 3, flat 4, and flat 5. This I'm doing using the singleton object, right? This I'm doing using the singleton object. So I've created one function, then calling this function 5 times. I'm calling this function 5 times. Can I use this same thing in class? So if I write the same code in class, I'll right click in this Scala, go to Scala class and give a class name as flat calculation or area calculation of flat. We can write this class. Here I will create the same function. So let me use a copy paste method to save time. I'll take this to statement inside the function, inside the class. This is the function, right? Area. And then you'll create one instantiated. Here in class, you have to instantiate this to call this flat call, because we know class is a white print. It's a blueprint. It's a white project, and we will have to instantiate when we want to access this area. And what is the instantiation? You create one object. You give a name as, let's say, flat div main method. And then you start creating an instance. You say, well, f is equal to new flat call. Then you start printing this. Print same printing. So let me copy this all 5 line, print it here. Okay. By the way, this is not required. This println statement is required. This is also not required. So all calling a statement I'm removing this, where I have assigned a function to a variable, I'm removing that line. You'll have to, so I think I forget, I by default remove that. By mistake, and I remove that instance. So I'll recreate that instance, not a problem. New flat call. And then this f will call. So this is one object now of your function. So this f will call the area and pass that to value 40.00 comma, and this is float, right? So I will have to write float here. This is 18.00f. Similarly, you will take some other value, 38 and 15. Third value, 42, 26, 25, 20, and 29, 21. If I right click and print this, I'll get the same answer. So I'm just telling you guys one approach, that one answer I can get using multiple approaches. Not necessary that you have just one approach or one code to get the output. But here one problem is there. Every time I'm calling this function, so if you read this code, how your compiler is going to call this? Your compiler will call the main method first, which is line number 11. Always your compiler calls the main method. Then immediately it will go to f, which is an instantiated variable or object of your this class flat call. Then println, within double quotes we have some string value. f is my object of class, or this is one instance. From here I'm calling area. So as soon as I call this area, immediately this will go here, and then it will check two values. This length is mapped with this value, then width, and then using this to multiply 40.0 and 18.0. Similarly, I'm doing 5 times, which means I'm calling this function 5 times. Remember, one call, so my loop of the function call will run 5 times. One time, second time, third time, fourth time, fifth time. Since they're calling 5 times, they'll occupy a space in memory. Every time they're taking total 4 byte and 4 byte. Similarly, 4 byte, 4 byte. And for all this function, they will take every time 8 byte. In each call, they will take 8 byte of total size. 8 byte, 8 byte, and 8 byte. After this, if I think to create a constructor, so now I'm going to run a concept of primary constructor. Constructor you define within the class. Here you'll say, well, length is float, comma, well, width is also float, length is float, width is float. So you have assigned these two values. You assigned these two values in your constructor site. When you want to call this, no need to assign this now here, right? No need to assign this in function. Length and width you're taking from your class itself. Function is using just a function body. Now I cannot directly call this function. I'm not passing at the time of function creation or function calling. How this will work? This is a primary constructor, okay? Whenever you define anything with your class, whenever you write any value with your class, which is length and width, this is known as a constructor, right? So since this function flat call is looking for two argument, always read the error. If I keep my cursor here, you can see unspecified value parameters length and width. This is missing, that's why they are giving me error. And now I'll write two values here. So can I write this two values here? This is one instance I've created for flat call. Then when I'm calling second time, well, f1 is equal to new flat call, second value. This will also give me the same answer, guys. F2. So this is the third approach, but using constructor. So you can search today, take that as an assignment. what is the difference between function and constructor? New let call, fourth value, well, f4 is equal to new let call and last value. Remove this print statement, not required, and call the function then, right? Call this function every time. Say print f dot area. 5 times you need to call f dot area here, because obviously 5 output you want to print, so 5 times calling f area, f1 dot area, f2 dot area, this should be println, right? For better formatting, println, 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 and println. F3 dot area, println, f4 dot area. Right click and run this. If you want to format this again with before this, you can write some double quote and add this statement. So this is the answer. All the time same answer, okay, but 3 different approach. Now what is the benefit here? I'm not instantiating this 2 variable in the function. This is not holding any argument, right? Can you see this function? This is not holding any argument. This is absolutely blank. When I'm calling this function from my constructor, which is first call, okay, when I'm calling this function from my constructor, the total time it is taking is less than the function call. Why? Just one reason, and then we're done for the today. One reason, by the way, you can check this out. Okay, there are some theoretical points in function and constructor side. So area is not compiled or storing their argument when you compile it, but this call every time, this call every time, this call just one time at the time of class compilation. So when you compile the class, this is only call once, this is call every time. So if I'm calling just one, let's talk in math. If I'm calling just one, it will take 8 byte only, 4 byte for this and 4 byte for this, which is 8 byte. So 8 byte they have taken and compiled and stored in a class. But here, this is calling every time. So every time 8 byte, 8 byte, 8 byte. You can understand the CPU computation time. So CPU will take more time to compute your function if you're creating large functions. To avoid those series, we have the concept of constructor. So we can use this constructor, which is a primary constructor, secondary constructor, or auxiliary constructor. We'll see tomorrow.